Welcome to episode 2 of Coffee with Your Coder. We've been compiling our questions throughout the last couple weeks, and wanted to bring you our 5 most commonly asked questions that we've gotten from February now going into March. So I'll get going here. All right. This one is, how long do AR coatings last? This is a good question. So really, it's dependent on the environment that the AR coating is going to be utilized in. A lot of times AR coatings, if it's in some sort of device or measurement instrument that's going to be sealed away and used in a laboratory and responsibly cleaned on a regular basis, AR coatings can last years and years and years. Now, if it's going to be on a battleship, on the deck of a battleship, getting salt spray and the out in the elements, then it's going to be a lot less time. The other thing to keep in mind is how long is the substrate going to hold up? If there's a lot of thermal cycling with glass or especially with plastic, as that surface changes, it gets softer, and then stiffens again. As that surface continues to change, expand and contract, the film is going to expand and contract with it, and that over time can stress a film. So really, it's all environmentally based how long a AR coating will last, and that's one of the things you'll want to ask yourself when you're designing your optical system. Is what type of environment is this going to be used in, and what's a real world application for the abrasion testing, for the adhesion, that sort of thing. Again, if it's a laboratory application that's in a climate controlled room and it's sealed away, then you probably don't need a real severe abrasion and heavy requirement there. So really it's case by case basis, but the environment is really what's going to dictate how long an anti-reflective coating is going to last for. All right, next question. All right, are anti-glare and anti-reflective coatings the same? So I guess we're going heavy with anti-reflective coating questions, and that's a very common and heavily produced coating we offer, so it makes sense. Anti-glare and anti-reflective coatings are 2 separate things. They can be used in conjunction with each other, which can get a little confusing. But talking through the differences with them, anti-reflective coatings are vacuum deposited coatings, usually multiple layers of metal oxides in varying thicknesses that produce something called destructive interference. So these coatings help actually pass light through your substrate more efficiently, and as the title destructive interference says, it destroys light waves as they hit the substrate. Anti-glare coatings are typically a wet applied coating, either dip or spin applied, and they have a bunch of diffuse particles in the film that kind of bounce light around on the surface of the substrate. So they're using a principle called constructive interference. They're both very different. So anti-reflective coatings, if you want to optimize your light transmission and reduce any surface glare or hot spots, that's the more applicable coating. Anti-glare coatings, those are used a lot of times in display applications or in applications where there's there's a little bit of an air gap in the display cover and the display itself. They can be used in conjunction, like I mentioned before, and in these cases, it's an outdoor light readability situation. You'll see this on ATM screens. ATM screens will typically have a anti-glare coating on them, but then they have an anti-reflective coating over the anti-glare coating. So they're 2 different technologies, 2 different wave processing technologies or theories that are happening there, and 2 different application methods, but a lot of times they're mistakenly used for each other, anti-glare and anti-reflective coatings. Good. All right, so next question. How do you make anti-reflective coatings? So anti-reflective coatings are typically applied under vacuum, and again, they're an alternating series of metal oxides. There are also single layer anti-reflective coatings, but most modern anti-reflective coatings are multi-layer metal oxides, and they're typically applied in a vacuum chamber. There are different application methods, but our method is an electron beam will actually actuate, and it will vaporize a metal oxide material in a crucible. That metal oxide will actually sublimate, or it'll go airborne into a cloud, and it'll be vacuum deposited onto substrates that are typically suspended above the evaporative source. So that's one method of creating an anti-reflective coating. So the coating itself is designed, you essentially figure out the refractive index of your substrate, and what you do is you layer different metal oxides on top of your substrate until you basically negate light rays coming through, or at least as much as possible. So that's typically how anti-reflective coatings are made. What is better, electron beam evaporation or sputtering? This kind of goes back to the anti-reflective coating question. So electron beam evaporation and sputtering are two different technologies used for coating applications. Both occur in a deep vacuum coating chamber. Electron beam evaporation uses electron beams to actually zap or actuate different oxide layers or different evaporative materials to create your coating. Whereas sputtering uses an electron beam, an ion beam, or a magnet to actually evaporate material from a target. So it's a set target that is your evaporative source, and you're bombarding it with high energy from a source like an electron beam or an ion beam. It really depends on your application which one is truly better. It's kind of, it's Apple versus Mac, or an Apple versus PC kind of situation. What are you using your coating for? And how are you measuring the efficiency? For high energy applications, indium tin oxide is a good example. Ion beam sputtering or sputter applications are, you can get a tighter packed film to achieve a lower sheet resistance. Additionally, in multi-layer coatings, like 70 over 100 layer coatings, sputtering is sometimes used because, again, you can pack that film tighter and it's a higher energy application. Now, electron beam evaporation can be used where you don't need to generate as much heat, and you can use it in coating plastics. You may not be able to achieve the sheet resistance with ITO or the high layers you can achieve with filter coatings in a sputtering application, but again, you open up a wide variety of substrates because you can control the heat a lot better, and it's lower energy process. So that's really the difference between the two. There's not really one that's better, so to speak, but they're really application dependent. All right, and one final question. What is the coolest application of AR that you've coated? So yeah, it's interesting. A lot of times, as almost a tier 3 supplier, we don't quite know exactly where some of the optics we use are going to be applied. We don't know what the application is, but I would say one of the most interesting applications that we've worked on was for a pretty well-known electric car company, where we custom engineered an anti-reflective coating for a very large center stack display. Worked with some engineers from this electric car company and figured out the optimum viewing angle for the driver of the car and the passenger of the car, and custom engineered an AR coating that then went into the alpha and beta builds of a pretty well-known electric sedan. So that was kind of cool to be involved like right at the front lines as they were conceptualizing this giant center stack display in a car, something that had never really been done before, and now is on every model of car they make. So I think that was probably one of my favorite things or one of the coolest applications I've ever been a part of. So yeah, that was Coffee with Your Coder, episode 2. Thanks for tuning in. Make sure you subscribe And make sure you're checking out all our social channels. Happy to connect with you anytime. And always check us out at www.nacl.com for data sheets, to send RFQs, or just to learn what we're up to. Thanks again. Take care.